Yes, hello everyone. Welcome back. We are looking at pre-purchase inspection AI part B, and here we are focusing on the commercialization of our system and our project. And we came up with the name of Vehicle Diagnostic AI. Yeah, because we are concentrating on vehicles and in the pre-purchase inspection. Yeah, so our target customers will be buyers of used cars and mechanics that will be using the system. So we deployed the system as a application. Yeah, and we have a simple video that demonstrates how our system works. And I think we can first watch it
Hello,
and
so
look at
this
it.
is a simple demo showing the deployment of our system for the pre-purchase inspection AI. Yeah, so we use the Streamlit app to help us with the deployment. And as you can see, it is a web application that you will be able to use, and you can access it through the link that I've shared. So the first thing you have to do is to upload the engine audio, the audio of the vehicle that you have gotten, of which you can choose in uploading when you come here to browse files. You can either choose to record the audio or you choose to obtain an audio that you have already recorded previously from your files. So our system uses WAV files and not MP3 files. So in case you get your file, you'll have to first convert it to a .wav file so that it can easily be processed. So after you have successfully uploaded your audio, as you can see, I have a sample here. As you have after successfully uploading it, you can be able to preview it here and play. That has been a sample of how the engine sounds. Then here, as a mechanic, you can go on to add some of the information about the vehicle. Now, after this, you come and analyze. It will carry out the GNN, and the other models will be trained. So when the model is trained successfully and the analysis is complete, you come back here and we check here on results. So on results, you'll find when the audio has already been classified as either normal or abnormal. So you'll see that it's abnormal. The scores will be seen above. The estimated repair cost of the engine will be given to you, and the issue that the engine is facing will be given to you. For example, an engine misfire, and probably after calculating the repair cost and the vehicle's price, it will estimate the final price of the vehicle that you wanted to purchase. Yeah, so other details can be seen below, and for an exclusive uh, report, you will find it here down, which will explain various things connected with the fault that you have detected. You can go on to download the report. In case of more information, you can get from here, which breaks down how you can be able to use it. Yes, thank you very much.
Yeah, so that has been a sample of the document. A sample of our system and how it can be used after our deployment.
Hello, so this is a simple
Yeah, so moving on, we see the problem space, and purpose. So our objective is to identify and detect faults in engines so as to provide their repair costs and final price of the used cars if purchased by customer. So our main problem is that the highest number of vehicles are used cars in Uganda, and they come with mechanical faults. So buyers lack the expertise for pre-purchase inspection, and in turn they end up buying overpriced vehicles. So one of the people who experience it mostly will be used car buyers, uh, who will be overpaying for vehicles that don't fit the price they're paying for, and mechanics also are other users that will need it for advanced tools to carry out pre-purchase inspection. Then why is AI essential in our project or in our system? It is because AI has complex acoustic pattern recognition for human hearing. It provides real-time analysis and uses knowledge graph integration for accurate cost estimation. Then the measurable impact is that there will be there will be a reduction in faulty vehicle purchases by used car buyers, which will save them a lot of money. Moving on, we see the users, stakeholders, and ecosystem actors. Primary users being used car buyers, vehicle mechanics, and vehicle inspection companies. Then we have secondary stakeholders, which will include the URA, which is Uganda Revenue Authority, and insurance companies, in case someone wants to insure their vehicle, or in case certain taxes are going to be charged on the vehicle that has been purchased. Ecosystem roles, we see that as suppliers, which include mechanics and the car owners. We have API consumers that are the used car bonds in Uganda. Then platform maintainers will obviously be our team that has developed the project. So government entities, for ethical compliance, will include the Makerere University Ethics Committee, then Uganda National Council for Science and Technology. Yeah, so data source and value, the sources of data that we use to develop our system. Data types we include audio, where we have the engine sounds. We have text, which includes the vehicle models and their prices. Then tabular, which is almost the same, repair prices and used car prices. Yeah, sources of our information. Of our The sources of our resources that we have used include car engine sounds datasets that we obtained online, and we have a vehicle detailed database as well. We also carried out synthetic uh, augmentation of our data, whereby we generated more engine sounds. So we also Moving on to the processing pipeline is broken down into simple steps where we have the audio collection, noise reduction, audio processing, classification, validation, and storage. Ethical and legal frameworks include compliance to Data Protection and Privacy Act of Uganda in 2019. We also have anonymous data collection, informed consent from customers. Then the value mechanism, it is through subscription fees for accurate diagnostics. So after developing our project, people who want to use the system will have to be paying a given amount of subscription fees. Then solution and AI system description. Here we break down the methods and the models that we use. We used acoustic signal processing, transformer models, graphical neural networks, and natural language generation. So as we have seen before, inputs included audio recordings, vehicle information, vehicle price, and repair costs of engines. Then the output will be fault diagnostics, repair costs, and price adjustments, as you had seen in our deployment video about the output that we received. So the AI decision process involves audio feature extraction, graph-based reasoning, and cost calculations with report generation as well. Then integration will include a web application for users. As you have seen, it's not a mobile application, but it's a web application that users can access and use it to implement the pre-purchase inspections. Yeah, responsible AI, we have explainable AI like Sharp, which values feature importance and helps with bias control to help improve our system. Yeah, key metrics and evaluation. We have technical metrics. Our system has an accuracy of 92% fault detection. We have a latency of uh, less than 5 seconds per analysis and an uptime of 99.5 availability. So we see there is more of the user centric metrics. We have the ethical metrics and the business metrics, which include customer acquisition cost of 8,000 per user. Then we also have the other costs, the raw AI, and how we shall benefit in the long term of our business. Yeah, the unfair advantage and differentiation that we have with our system is that there is proprietary assets where we use a local database of vehicles in Uganda because we have to know uh, the information of the vehicles, like their prices and how they're being repaired, and the common faults that are detected in the vehicles. So it will we shall use noise graphs for local repair costs and parts, and also use patterns for audio analysis algorithm. Then when we develop our system, it won't just be used by anyone, but it will be having patent rights that are only eligible to us. Then feedback loops, we use continuous learning from mechanic validations. We use user feedback to improve our system and diagnostic accuracy. And also we keep on updating based on the market price data to refine cost estimations. Sustainable differentiation. What will differentiate our system from the others is that it will be localized, especially for the Ugandan market, since it's our main target. And for low connectivity areas, we shall improve the system so that it can work even when there is a limited access to the internet. Channels and distribution, we shall use social media for campaigns, uh, platforms like Facebook and YouTube, delivery channels. We shall try using the Play Store, using WhatsApp Business, and also web application. Partners will include University College of Engineering, that is SEDAT. Then we have Uganda Automobile Association. Retention tactics, how we shall retain our customers, include regular model updates and also offering discounts to our loyal customers. Revenue streams are the breakdown of how we shall obtain revenue from our project. Direct revenue will include subscription fees, as we have said, 50,000 per month. Dealership license, if someone wants to access a license to our system, they will pay 150,000 per month. Then for each scan, will cost just 5,000 shillings. We go on to direct revenue models. We have data analytics. We shall also offer premium uh, parts and also some parts that will be free in our system. So it will depend on how the user wants to use the system, but we shall provide some basics that will be free and also premium detailed reports. Uh, there will be value added services for extra feedback and improved services that customers will need. Key resources, looking at how we shall break this down, human resources shall need two machine learning engineers, two data scientists, one mobile app. Though as for now, based on our project, we are only three, but for better improvement, we shall need a good number of technical personnel to improve the project. We shall use infrastructure like cloud, AWS. We shall have an audio repository of which we shall be obtaining audio samples and we shall store there. Then financial resources to come up with our project fully developed system. We may need around a cost of 5 million. Yeah, so model life cycle, as we have seen, there is daily data collection from partner garages, weekly model training, monthly performance audits. We shall develop the project, the application, even to mobile devices. Yeah, providing governance compliancy and also customer services like using WhatsApp for training and also uh, obtaining feedback from our customers. Our partners will include AWS Active Program. We shall also use Makere AI Research Lab, and data partners will include Kachivanda, Kushi Motors, S-Line Motors. These are bonds that sell used vehicles in Uganda. Ethical oversight, we shall also have data protection office in Uganda. Distribution partners will include Jumia and DG Uganda that we shall use for advertising our system. We also have the strategic collaborators that will include Innovation Village Uganda and MasterCard Foundation. Cost of the structure, here is a breakdown. The data cost, the computing infrastructure, human resource, compliancy and market distribution, governance and ethics, how we shall maintain all this. We can see in the slides above, scalability and sustainability, intellectual property and innovation, how we shall maintain the system to be used by ourselves. As I had said before, we shall have patent rights to our system. We shall also use knowledge graph structures that will be copyrighted so that it's not just used by anyone. So we also have novelty aspects, uh, fast acoustic based vehicle inspection system for Uganda. So it will be it will be one of the first systems to be developed. So there will also be a novel prize for that. Then innovation highlights, as you have seen how our project works, because it combines different models to come up with our desired output that includes a detailed report. Yeah, so our team included of three people with their contributions as seen in the slides. We have Henry that helped in the web app development and the deployment. Then I myself, Jamevic Tayope, I helped in the model development and testing, validation as well. Then Adero Brina helped in data collection. Yeah, so thank you very much for this time and for listening. Yeah, if you have any further questions about the system, you can contact us through our emails. And if you want to access the system, there is a link. There is our link that you can use to access our system and use it. Yeah, thank you very much. Have a nice one.